Hello my dear students, this is your host Dr. Syed. Today let us study about the sterilization techniques. Sterilization ensures the purity and safety in microbiology. It is one of the most essential steps in microbiology in order to avoid contamination and in order to grow microorganisms in pure form. It is one of the standard laboratory techniques practiced in R&D, healthcare sector, pharmaceutical and other industrial processes. There are different means of sterilization. You can sterilize the glasswares what you use to culture microorganisms, or you can sterilize the media to grow microorganisms. There are different techniques depending upon the type of component what you are looking to sterilize. The first instrument what we use is autoclave. Autoclave is nothing but similar to pressure cooker. Here, under the influence of heat and pressure, the microorganisms are destroyed. In autoclave, we usually make sterilization process very easy for glassware, media preparations, etc. So it is one of the handy instrument available in all microbiological laboratory, and this instrument is one of the fundamental instrument in the microbiology laboratory. In this video you can view that it's a stainless steel instrument where the required components, glasswares or media are placed in this instrument. Once this is placed, it is covered with its lid, and under the influence of heat and steam, the media and the other components is autoclaved or sterilized. Along with this, there is other means of physical sterilization, that is via dry heat sterilization. Dry heat sterilization is usually practiced when you wash the glasswares and you will keep this so that under dry heat with high temperature the glasswares get sterilized. Here you can see the different temperature practice: 160 degrees Celsius for 2 hours or 170 degrees Celsius for 1 hour for most of the conventional dry heat sterilization, whereas a 190 degree is practiced for 6 to 12 minutes for high velocity hot air sterilizers. Similarly, 250 to 400 degrees Celsius is also practiced depending upon the type of component you are looking for autoclave or sterilization. So this is a dry heat sterilization process, and here you can see the dry heat sterilization instrument. It is majorly practiced when in the case where moisture may compromise the integrity of the material what you are looking for sterilization. This is majorly practiced in most of the healthcare sectors. Here you can see before the operations or any surgical practice is carried out, these instruments are meant for sterilization, and majority of them use heat sterilization process. Along with heat sterilization process, which is one of the means of physical sterilization, there are certain chemicals which are used for sterilization, and these chemicals comes under chemical sterilization process. When the traditional heat based methods are impractical, then chemical sterilization are practiced. Some of the examples are ethanol, phenol, carbolic acid mixtures, ethylene oxide, etc. And these chemicals penetrate into the pathogenic microorganisms and they kill them and prevent their growth and multiplication. Majority of medical devices and packaging material follow chemical sterilization process. When the component or the product is heat sensitive, chemical sterilization process is practiced. Moving on to the applications of sterilization, the sterilization process is carried out in hospitals, big research laboratories, industries, etc. Every industry, it might be food industry, pharmaceutical industry, drug industry, etc. Everywhere sterilization is one of the most fundamental laboratory practice. The importance of sterilization, the basic and thumb rule is to prevent the infection, to prevent the contamination, to reduce the microbial load from the given sample. Along with this physical sterilization process, there are certain materials or compounds which are used as a disinfectant. Since our childhood, we have been hearing about disinfectant. This disinfectant is nothing but a chemical compound which are practiced in healthcare facility, laboratories, home and public places. For example, bleach, sodium hypochlorite is effective against a broad spectrum of microorganisms. Similarly, ethanol. Ethanol and isopropyl alcohol are commonly used for disinfecting surfaces. And recently, due to COVID-19, we were practicing we were practicing the use of alcohol in order to wipe our hands and surfaces. Similarly, hydrogen peroxide acts as one of the potent disinfectant and can be used on surface wounds and in oral care. Similarly, ammonium compounds are also used in many household instruments to wash and is used as a disinfectant. UV light. UV light has the characteristics of killing or suppressing the growth and multiplication of microorganisms. UV light can be divided as or categorized into three types of UV lights: UVA, UVB and UVC, among which UVA and UVB are effective against pathogenic bacteria and fungi, whereas UVC is effective against both bacteria, fungi along with viruses. So UV light is also practiced, especially when you go to a dentist, they follow this practice. Air filtration. As we all know, air carries microorganisms and other spores. Hence, in order to filter air, there are various air filtration techniques which is in practice using different filters. One of the best example is HEPA filters. This is used especially in laminar airflow in order to maintain the sterile conditions. Antiseptics. Even this we have been hearing since our childhood. It has been practiced in our homes. Antiseptic agents, antiseptic creams, antiseptic solutions. The best example is Dettol, where if there is any wound, we have a practice of wiping that wound using Dettol so that it prevents the infection to spread, which means it will destroy or inhibit the pathogenic microorganism to enter the cut or a wound on our body. There are various types of disinfectant used: skin disinfectant, vaginal disinfectant, mouth and throat care disinfectant, wound care, hand hygiene care, etc. Some of the most popularly practiced disinfectants are iodine-based solution, alcohol, hydrogen peroxide, etc. Germicide. Germicide, the name itself indicates it will kill the germs. You have been watching on television various products which term as germicide, and they are used in cleansing various products and cleansing the bathroom, etc. So these germicides are the compounds which are having the potential to prevent or kill the growth of various broad spectrum pathogenic microorganism with different mode of actions. Fungicides. Fungicides are one of the essential component in the society. These fungicide prevents the growth of fungi. The major applications of this fungicide you can see in the agriculture field. There are various types of fungicide which target the specific species and kill the fungi which is causing disease or affecting the crop cultivation. Some of the common fungicides are having the combination of copper compounds, sulfur, triazoles, etc. Virucides are the agent which are having the capacity to inactivate or destroy viruses, and these virucides are used in order to disinfect the surface object environment and reduce the risk of viral infections. Bacteriostatic agents, these are the agents that inhibit the growth and reproduction of bacteria without necessarily causing their immediate death. The term bacteriostatic means bacteria means against the bacteria, static means stopping, it's suppressing it. The bacteriostatic agents interfere with the essential bacterial process such as protein synthesis, DNA replication, and cell wall formation. Some of the most commonly used bacteriostatic agents are tetracycline, erythromycin, sulfonamides, etc. Whereas bactericidals are the agents which kills the bacteria, whereas bacteriostatic agents are the components which stop the growth of bacteria, whereas bactericidal kills the pathogenic microorganism. Even here the mode of action is similar to bacteriostatic. Here the bacterial cell wall is ruptured and it interferes with the vital cellular processing and prevents the growth and multiplication of bacteria, pathogenic bacteria. Some of the best commonly practiced or examples are penicillin, antibiotic, cephalosporin, antibiotic, vancomycin antibiotics, etc. As we discussed in our previous slide, bleach, alcohol, hydrogen peroxide, and ammonium compounds are widely in practice. And we also have phenolic compounds which are effective against bacteria and some viruses. They are used as a disinfectant and in the cleaning products as a major component. Iodine based disinfectants are also having broad spectrum antibiotic activity, antimicrobial activity, and are used in surgical scrub, skin disinfectant and in the treatment of water. Chlorine based antimicrobial agents are still in practice, wherein they are majorly used in the treatment of wastewater management, water treatment, surface sterilizing agent, and are also one of the major component in cleaning products. Similarly, formaldehyde, boric acid, etc. are also used. Tyndallization. Tyndallization is a method of microbial sterilization which is named after the Irish scientist John Tyndall. Here I will show you with the protocol or the procedure practice. Here it is a 3-step cycle wherein the Tyndallization process is carried out continuously for 3 days, in which the material is exposed to steam for approximately 30 minutes, and it is after 30 minutes it is kept as a resting period, and the same practice is followed on the second day and the respective third day. As you can see here, this is the Irish scientist John Tyndall. Steaming or boiling the product at 100 degrees Celsius for 20 to 45 minutes for 3 successive days with overnight resting period. The incubation at 37 degrees during resting period allows germination of spores into vegetative form. Then the next day when you practice this steaming tenderization process, these vegetative form will be killed. Moving on to the pasteurization. Pasteurization is the technique introduced by Louis Pasteur. And Louis Pasteur introduced this technique, which is also followed by various beverages industries, and they have been successfully able to prevent the contamination of microorganisms. In milk or dairy industry, it is one of the most popular technique. Here there are different types of pasteurization which is characterized. The batch pasteurization, in which the liquid is heated at 63 degrees Celsius for 30 minutes followed by rapid cooling. Whereas HTST, here high temperature short time pasteurization technique, where different temperatures are being practiced with at different times. For example, 72 degrees Celsius. At 72 degrees Celsius, the sample is heated for 15 seconds. 89 degrees Celsius, the sample is heated for 1 second. Like this, they have been practicing HTST pasteurization process. Now, even the ionization radiation is also one of the means of sterilization process. The best example for this is sunlight. Sun drying also prevents the microorganisms to grow. The basic principle behind this is, once a compound or once the product comes under the influence of sunlight, the moisture content will be completely removed, which doesn't allow the microorganism to grow. The radiations are grouped into ionizing radiation and non-ionizing radiation. When it comes to ionizing radiation, here ionizing radiation has sufficient energy to remove tightly bound electrons from atom, creating ions. This process can lead to chemical changes and damage to biological components or biological meiosis. And this principle is practiced in the form of sterilization. Also, these ionizing radiation are also used in lab in biomedical application. For example, X-rays are used in medical imaging and other industrial application. Gamma rays are also used. And coming back to its application, they are also used in cancer treatment, industrial radiography for inspecting materials and structure, sterilization of medical equipments, etc. The larger exposure time can also cause damage to living tissue and increase the risk of cancer. So safety measures are really important when you are practicing ionizing radiation. Similarly, non-ionizing radiation, these are having low energy levels, and here some of the different types are radio frequency, visible light, infrared, UV rays, etc., which comes under non-ionizing radiation, and also microwave radiation. The application part is, they are all, along with sterilization agent, they are also used in telecommunication, broadcasting, and they are used in cooking in the form of microwave ovens, phototherapy for skin condition using UV light, etc. Laminar airflow. Laminar airflow is a chamber which maintains the sterile environment. While you are working with microorganisms, safety plays a very important role. And in order to create a safety environment, and in order to create an aseptic environment, all the microbiological experiments are carried out within laminar airflow. The laminar airflow is equipped with HEPA filter, and this HEPA filter purifies the air and circulate the air within this laminar airflow. and this results in maintaining the hygienic or sterile conditions. So with this class we were able to study the different means of sterilization techniques. What do you mean by disinfectant, what do you mean by antiseptic, germicides, sanitizers, fungicide, virucides, what are bacteriostatic and bactericidal agent, chemical disinfectants and its type, sterilization by means of physical agent, heat, moist, dry heat, boiling, sterilization, pasteurization, autoclaving, radiation means of sterilization, and laminar airflow. The inoculation and incubation we have discussed in our previous class. If you have missed it, please do watch that video. And with this, let me conclude this class today and see you in my next class. Good luck.